So this section is called Two Basic Counting Principles, and the first one is the multiplication principle. And whenever you guys use it, I want you to understand that you're using it, and because of that, I want you to cite it. But that can become tedious, so I'm going to say we can abbreviate it as MP, and I'm fine with that. So what does this tell us? Well, the first thing it tells us is, suppose we have a sequence of events like we did in the previous one. It can be broken down into M successive events where there's R1 possible outcomes in stage 1, R2 possible outcomes in stage 2, RM possible outcomes in stage M. Now, how does that relate to what we just did? Basically, this would be 2 possible outcomes in stage 1, which would be include 1 in the subset or not include 1. Basically, I want you to break this down to a series of decisions, and each one is a stage. So the stage is basically deciding whether or not to include 1 in the subset. So for each of these, we have the numeric value, how many choices we have, and what we're doing, choosing whether or not to include an element in the subset. Okay, so that's part 1 of multiplication principle. There's 2 other additional criteria we need. It says the number of outcomes in each stage is independent of the outcomes in the previous stage. And we're going to have to come back to that on the next page, because it's important we understand what does it mean to be independent. And I'll just paraphrase what we're going to talk about. That is, there is only one possible value, Ri, at stage I. And the following is that all composite outcomes are distinct. Now, we don't even know what a composite outcome is, so that's definitely something we need to discuss in detail. So there's 3 things here. We have to be able to break things down into R1 possible outcomes in stage 1, R2 possible outcomes in stage 2, and RM possible outcomes in stage M. And we need to say that the number of outcomes in each stage is independent and that the composite outcomes are distinct. Now, for now, this is just math speak. We need to dissect what these things mean. But if all 3 of these criteria are true, the total number of outcomes for the procedure is just multiply them all together, like we did in the previous one. And I'm going to use this pi notation, which means multiplication. It's the product from 1 to m of the RIs. So this says when 1 through 3 are true, we can multiply things together by multiplication principle. And that means I'm going to go back here and I'm going to say our answer here is by MP, multiplication principle. Now, before we can go further, right now we just have a bunch of arbitrary things written on the page. We need to understand what 2 and 3 mean in order to be able to use them. I hope you guys understand what 1 means, that we have 2 choices per each element we chose for the previous problem. So what does it mean for our steps to be independent? Well, let's consider a problem. Suppose we wish to draw 2 cards from a 52 card deck such that the second card is a 2 and the first card is anything. Well, it's a 52 card deck, so the first thing I'm going to do is draw card 1. I can draw anything I want, so I'm going to say there's 52 ways to draw card 1 because it can be anything in the deck. Now, step 2, draw the second card. Well, this is a little bit more tricky. I need to draw a 2. Remember, that was our stipulation. The second card is a 2. Well, here's the problem. Suppose the first card I drew was a 2. Well, then there's 3 choices if the first card was a 2. Because a deck of cards has 4 2s in it. So if I drew one in the first step, there's only 3 remaining in the deck. So how many choices do I have? 3. But suppose I didn't draw a 2 in the first step, then I have 4 choices. All 4 2s remain in the deck. Well, in order to be independent, I could only have one answer for step 2. So I'm going to say, since the answer in step 2 depends on the answer in step 1, steps 1 and 2 are not independent. And it's not that I hadn't to consider step 1. If the only possible answer was a 4, I still would have had to consider step 1. That's fine. You can still have to consider step 1 and step 2. The important part is I can't have these 2 different answers, which is why we phrase this, there is only one possible value, Ri, at stage I. Okay, now let's talk about composite outcomes. What are the composite outcomes? In the subset example we did earlier, which was example 1 and 2, the different subsets were the composite outcomes. They're basically the end results that we get when we finish counting. Now, I'm going to say, consider the example above. The composite outcomes, and by the example above, I mean this drawing 2 cards, would be maybe the King of Hearts, and then the 2 of Hearts would be one composite outcome. Or the King of Hearts and the 2 of Spades, or the 2 of Clubs. Or the 2 of Spades and the 2 of Diamonds. All of these are composite outcomes from this example where we had to draw any card first. And then the second card had to be a 2. So I'm going to say note when applying multiplication principle. We want to make sure the composite outcomes will be different. That is, we don't want to get 2 of Spades, 2 of Clubs, and then get it again, and then get 2 of Spades, because that would be a repeated outcome. So that's another important thing for us when we do composite outcomes. We need to make sure they're distinct whenever we have composite outcomes. They come out different. Okay, one more context before we're done with multiplication principle, the basics. Another context for multiplication principle is to consider each element in a set S as a uniquely specified by a sequence of M choices or decisions. This might be a better way to think about our subset example where we have R1 distinct choices in set 1. And this is kind of like saying we have 2 choices to include element 1 or not. R2 distinct choices in set 2 all the way up to RM distinct choices in set M. And then set S will have R1, R2, R3, RM, elements. It's just another context because we will often refer to multiplication principle, I'm abbreviating it here, as making a sequence of decisions. Now, this was a lot of theory, but just to summarize, big picture idea, we can apply multiplication principle when we're making a sequence of decisions. We have a certain number R1 possible outcomes in the first stage, R2 in the second, RM in the mth. Now, we need to make sure that when we are making our R1 value versus our R2 value, R2 cannot be a separate number based on our R1. That's called making sure the number of outcomes in each stage is independent. We also have to make sure that the composite outcomes, the sets that result from us making this sequence of decisions, will all be distinct. And those are the principles for multiplication principle. So let's apply it.